Okay, here are quiz 8 solutions for math 65. Question 1 gives us a couple different polynomials and asks us to factor them. For the first one, it's kind of if you have this formula memorized, you're good. If not, you don't really have any chance. It's our difference of cubes formula. It looks like this. And so really what you have to do is look at this and recognize that in fact I have a difference of cubes. X cubed is x cubed, and 8 is 2 cubed. So I guess you have some options on how you write this up, but one way you could write it is you could say really what this question is asking me is what is x cubed plus 2 cubed. And so you look over here and you're like, well, if it were a cubed plus b cubed, I know the answer. But it's not, it's x cubed plus 2 cubed, so the a is x and the b is 2. So if you just copy this, except everywhere you see the letter a, replace it with an x, and everywhere you see the letter b, you replace it with a 2, what you'd end up with something like this. 2 squared, but 2 squared is 4. And that's the answer. That's factoring this polynomial. If you have this formula done, no problem, but if you don't, kind of impossible. Alright, moving on. The second one a little bit trickier, or at least I thought so. It almost looks like a difference of cubes, I guess, or maybe a sum or a difference of squares, I don't know. It's neither of those the way it's written. The way it's written, what you're supposed to notice is that we have a greatest common factor. Right? Each term has an x in it, so I could factor out that x. And if I did so, I'd be left with 4x squared minus 9. And now I have a difference of squares. Right? 4x squared is exactly 2x squared, and 9 is 3 squared. So I got 2x plus 3, 2x minus 3. Then that would be my answer. Maybe I'll throw a box around these guys, although it's pretty obvious which my final answer is. Alright, moving on. 2 seems very different. In 1 it's asking you to factor polynomials, and 2 it's asking you to solve equations. Turns out it's quite similar. So what you're doing here, if you're solving equations, quadratic equations, meaning you got x squareds and you got x's, the strategy will be to factor. It only helps to factor if the equation is set equal to 0. So before we even get started here, we're going to subtract 12 from both sides of the equation. So instead of x squared minus x equals 12, I got x squared minus x minus 12 equals 0. Now my equation is set equal to 0, which is a good thing, because when I end up factoring it, that'll be a key point. So we can factor this. It's a quadratic trinomial. Its leading coefficient is a 1. So if it factors, it's going to look something like this. Let's see, I'd need two numbers that multiply to negative 12 and add to negative 1. So the possibilities that multiply to 12 are 1 and 12, 2 and 6, and 3 and 4. But you want it to multiply to negative 12. So you're thinking, all right, one or the other of these numbers must be negative, because a negative times a positive is a negative. No way I can get to negative 1 from this pair or this pair, but this pair down here, if I made the 3 positive and the 4 negative, I'd be choosing two numbers that multiply to negative 12 and that add to negative 1. I'm not done at this stage. If this were a question in part 1, I'd be done. I'm done factoring. But in part 2, we really see why you bother factoring. And really what it comes down to is I now have something times something that equals 0. And the only possible way you can multiply together two things and have them equal 0 is if one of those two things is 0. So I can go from this line to this line. You can turn one equation into two equations. Might seem like you've doubled your work, but really you haven't, because these two equations are pretty easy to solve. For this one, just subtract 3 from both sides. For this one, add 4 to both sides. And what you have is your answer. Or I guess answers. X equals negative 3 is a solution to this equation, as is x equals 4. Try it, plug them in. What you'll see is when you change all the x's into negative 3's, you get 12 on this side, 12 on this side. 4, you get 12 on this side, 12 on this side. Alright, and then the final one. same basic idea here. It's an equation, we want to solve it. The way we're going to solve it is by factoring. For this specific problem, factoring will be a little bit trickier. It's kind of like this one, where when you first look at it, it doesn't seem to fit any of our factoring methods. We're not used to x to the third power. However, if you notice, we have a greatest common factor of x. And if you factor out that x, you get 6x squared minus 13x plus 6, which equals 0. So what that tells you is that either x equals 0 or 6x squared minus 13x plus 6 equals 0. Right? I have something times something else equals 0. The only possible way you can multiply together two numbers and get 0 is if this one's 0 or if this one's 0. Sweet, I just got one of the equations, or one of the solutions, x equals 0. That is a solution. But there's more solutions. We can find them by factoring this equation. So let's see, maybe I'll do this off to the side. Let's factor 6x squared minus 13x plus 6. You can either use the guess and check method and jump straight to the answer, or you can do this three-step process that we learned. The three-step process is first find two numbers that add to the coefficient on the x term and multiply to the product of the constant term and the leading coefficient. 6 times 6 is 36. So you think about that for a little while. Maybe I'll come up here and list all the possibilities for 36. You might not have to list them. Maybe you can already see the answer. But in case you can't, I'll list them. See, I want to add to negative 13. So to multiply to a positive number, they either both have to be positive or both have to be negative. But if they're going to add to negative 13, they better both be negative. So in this list, if all of these numbers are negative, which pair is going to add to negative 13? It's going to be these guys here. Got negative 4 and negative 9. And then step 2 is to replace our linear term, negative 13x, with negative 4x minus 9x. So what I'm saying is rewrite our equation. Instead of 6x squared minus 13x, we got 6x squared minus 4x minus 9x plus 6. And then finally, step 3 is factor by grouping. So to factor by grouping, you're like, I have 4 terms. If I grouped the first 2, their greatest common factor is 2x. And if I factored out a 2x from 6x squared, I'd be left with 3x. If I factored out a 2x from negative 4x, I'd be left with negative 2. Then you stare at this next group and you're like, I got to factor out something so that I'll be left behind with 3x minus 2. In this case, that something is a negative 3, because negative 9x divided by negative 3x is positive 3x, and 6 divided by negative 3 is negative 2. So now I have 2 terms that both have a 3x minus 2 in them. So I can factor out that 3x minus 2, and all that's left is 2x and minus 3. So all this work off to the side was just so that I could write, instead of 6x squared minus 13x plus 6 equals 0, I can say 3x minus 2 times 2x minus 3 equals 0. Because this is the same as this, as I showed over here. Why is that beneficial? Because it's something times something equals 0. So that means either 3x minus 2 equals 0 or 2x minus 3 equals 0. Either 3x equals 2, add 2 to both sides, in which case x equals 2/3 if you divide both sides by 3. Or if I add 3 to both sides, I get 2x equals 3, and then divide by 2, I get x equals 3/2. So what I found for this one is there's actually 3 solutions. X equals 0, x equals 2/3, and x equals 3/2. If you really wanted to, you could check those answers. Checking x equals 0 isn't that hard. They'd all go to 0. 0 minus 0 plus 0 equals 0. I wouldn't want to check the fractions, but you could if you felt like it. But I'm going to trust we did everything right. I'm just going to call that good and end the video there.